Okay, so just to continue 7.1, this is just from 7.1 because we didn't finish it. This is compound interest. This is where you get interest on your interest throughout an investment or throughout a year with a bank account, savings account, something like that. This is the formula, and these are your values. A is your ending amount, P is your starting amount, which is the same as y equals AB to the x, where your initial value is right here in the P spot. This is the growth factor, 1 plus R over N. Remember, R is annual interest rate. If you're compounding multiple times during the year, you have to take the annual interest rate and divide it into the number of compounding periods so that you get an interest rate per compounding period. That's how we get our growth factor. In the exponent position, it's the number of compounding periods n times however long you run the investment for, or the growth for. So A is your ending amount, P is called principal, and in money that's your starting amount. R is your annual interest rate, and N is how many times a year are you compounding. It'll say compounded quarterly, that means 4. Compounded monthly, 12. Compounded daily, 365, that type of thing. P is your time in years. Remember, this N variable appears twice. It appears in the denominator of R over N, and NT, make sure if you're using your calculator, put that in parentheses. Now, if you're doing this on a calculator, and I'll show it to you on a calculator in a minute, you've got to use parentheses correctly if you're doing this in one shot. Any questions on this formula? Everybody good on the formula? Got it down? That formula, I'm not sure that you have to memorize it. I think on the test we give it to you. T is time in years. T is time in years. Now we have our calculator ready for us. So let's look at an example, okay? And we'll take a look, same formula just from the book. So here's your example right here. You have a $4,000 investment, pays 2.92% annual interest, and you want to find out how much money you have after a year. So you can see it's already been done up here, so it's not something you're watching me do here. But here's the plug-in. Starting amount is $4,000. 1 plus your interest rate. Your interest rate has to be as a decimal. So you need to change 2.92% to 0.0292. Move the decimal 2 places to the left. Over 4, because we're compounding quarterly here. And in this example, we're only doing it for 1 year, so it's 4 times 1. This line right here, this line, this is non-negotiable in terms of what I need to see. You've got to have that written down. You don't have to have any work between that and the answer, but you've got to get that written down. So you should pull out your scientific calculator and say, well, hey, can I get $4,118.09? And if you can't, you might want to pay attention to what we're doing up here. Now, some of your calculators, Taylor, can't do it in one shot. So you have to start in here and find this quotient, then add 1, then raise it to the 4th, then multiply by 4,000. So you have multiple layers that you'd have to go through. If you have a calculator with parentheses, you literally are going to just type this in one shot. 4,000, open parenthesis, 1 plus. Now we've got to do a quotient here, so we need another set of parentheses. 0.0292, bless you, divided by 4, raised, and then again, you would normally have to put parentheses here to make sure you're raising to the product power. you wouldn't have to do that here because it's just a 4, but I'm going to enter 4 times 1 just for fun. That's the way it should look when you enter it on your calculator.
Why don't you get 0.02?
You mean right here?
Yeah.
The interest rate was 2.92%.
Yeah.
Move the decimal 2 to the left.
I didn't see that.
That was covered.
Yeah.
Then hit enter and get it wrong.
Oh,
Because I forgot to close my parentheses. This is what happened Friday. Okay? 4,000 after you guys left. One mistake after another. 1 plus, open parentheses, 0.0292 divided by, hey, that was your fault. Divided by 4.
Yeah.
Close parentheses, then raise to the power of 4 times 1. My ADD just went off the charts there. Got to pay attention. So we have an open here and open here. Then we have to close them both before we raise to the power. On your calculators, you should be getting the same thing, and we round to 2 places here. Why is that? Because it's money. So we got to round to 4118.09 because the right of the 8 is a 5, so we round up to 9. You need to know that it's money, and you need to round to 2 places. Yes.
Calculator a little. Can I see the work on it?
Or you want to see the calculator?
No, that's fine.
That's what you want?
Yeah.
No.
This work right here is a different problem.
No, I know.
Okay. Any questions on that? Getting this? Anyone not getting it? Same problem, only they changed to compounding daily. Same problem, compounding daily. See if you can get to the 4118, but this time you should have 0.52. Same problem, compounding. You're compounding daily. So what I'm plugging in here for the n is 365. And again, this is about, can you use your calculator? Can you make this work on your calculator? So today's stuff works exactly the same as Friday. It's the same notes. You look at this stuff, if everything is the same, y equals ab to the x, a has to be greater than 0, and, well, a isn't always going to be greater than 0, but b has to be between 0 and 1 today. What was the limit on b on Friday?
It had to be bigger than 1.
Had to be bigger than 1. Bigger than 1 means you have a takeoff or an exponential growth. Less than 1 means you have a landing or a decay function. But the values that you're graphing, it's still going to be left 1, up 1 over b. Right 0, up 1. Then right 1, up b. Sorry.
That's okay.
I'm out. That's some toilet paper right up here.
It's not toilet paper. Oh no,
Right
there
there.
is toilet. Why is that there?
What do you need to do right now?
Oh my nose.
That's why it's there.
Oh,
Okay?
that's a different towel.
No, it's not. It's definitely toilet paper.
Is it like a toilet?
There's toilet
You hate what?
There's actually toilet paper. So, let's go deep.
Huh? I gotta find a, there's gotta be an app for that, right? Sounds that bugs the page, like, we'll get a
Let's make it.
blowing nose. What else? Does vomiting make you feel bad too? No? Anything else? Nails on the blackboard?
Oh,
I love that.
I don't like writing
being annoying. Oh no, it's gross. I personally think it's disgusting.
It's
They also
disgusting. Well, you know,
chalkboard?
so you should all just go to this method.
Just like
If you want to talk about gross, watch a 4-year-old. That's gross. Ladies, donut all over their face. It's like you need a chisel and a hammer to get the snot off their face. All right, now here's the deal. When b is less than 1 and greater than 0, when b is less than 1 and greater than 0, it's going to change what happens on the graph. It's still write 1 up b, but b now is going to be a fraction that's smaller than 1. So write 1 up less than 1, write 0 up 1, and when we go left 1, we take the reciprocal, 1 over b, and we end up going up something more than 1. So that's why our graph ends up being a landing as opposed to a takeoff. Domain for exponential functions is always all reals. The range will be whatever your asymptote value is greater than or asymptote value for y less than. Always. All right, those are really easy to come up with. Domain is all reals. Range, in this case, is greater than 0. The parent graph, again from Friday, y equals a b to the x minus c plus d. I left out the horizontal stretch factor on this. We'll put it in when we need it. So b to the x is still your parent graph. C comma d is still your translation vector. And we're still having some challenges with c. C is the opposite of what's with x. D is what comes after the function. Vertical stretch factor is a. It's in front of whatever your base is. And your horizontal asymptote is y equals d, whatever the translation vector's y component is. These are the same notes you should have from Friday. They should be identical. We expect graphing to be mindless, at least I do. If you don't make the list on your graph, you will lose a point for each graph. If you do not have the list for each graph, you will lose a point. The only way you can avoid losing a point for not putting a list is if you come and see me and you say, look, my tutor wants me to graph this way. Fine. You show me the way that you're going to be graphing, and then I will tell you you don't need to make the list. Otherwise, my expectation is you're all making this list. And we're all graphing the same. What's the first thing that you do on your graph?
Make the
Draw the asymptote. All right? So we're going to start with just a parent graph. So when it's just a parent graph, you don't need a list. There's no translating, there's no stretching, it's just a parent graph. So first thing, we take and draw our asymptote, y equals 0. From the origin, in a different color than your asymptote, write 1 up,
1.
let's say,
B.
and b is 1/2. So write 1 up 1/2. Write 0
Up 1.
up 1. And left 1
Up 1 over B. 1/2.
2. Whatever b is, flip it. b is 1/2. When you take the reciprocal, you get 2. Make sure your graph is a landing graph. It comes down, hits your points, and then gradually approaches, but doesn't really touch your asymptote. I'm not super specific with my graph. I'm not asking you to find any other points. These 3 are enough. If you're really on it, when you go left 2, you'll know you're going up 4 on this one. Left 3, you're going to go up 8. It's not necessary to find those points, but here's what I don't want to see in a graph. I don't want you to have your 3 points and do this kind of a thing. And expect me to say, oh, that's fine. You have too many problems with that. For one, any plane that comes down along this vertical path, seriously, okay, this is not a nice gradual landing. People will sue. You need to have a nice, gradual, smooth landing. This red plane isn't even going to land. It's never made, not even coming close to the asymptote. This red graph is not what we're looking for. And you'll get marked down because you're not pushing. When I say push the asymptote, I mean come off your last point and approach the asymptote. Let's get that out. Okay. Any questions on this one?
So is the exponential thing H is kind of like a flipped graph of what B would be if it was flipped?
Yeah.
So if it's like 2, then
Yeah, it's the inverse.
all right.
Please don't work on it that way.
Okay.
You just right 1 up B, right 0 up 1, left 1 up the reciprocal of B, the same thing that we've been doing since Friday. No difference. Okay, here's y equals 1/5 x, another parent graph. The only difference on this is it's 1/5 instead of a half. So it's steeper on the left, and it gets quicker to the asymptote on the right. So when I go right 1, after we put in our asymptote, which let's try this flavor. So there's your horizontal asymptote. Right 1 up. How much?
1/5.
1/5.
Would be like half of that.
As long as you're below the half and above the asymptote, I'll be ecstatic with that. Right 0,
Up 1.
up 1, and left 1,
Up 5.
up 5. So you can see this is quite a bit steeper. Now, oh, Mr. Walker, you touched the asymptote. You said that was bad. It is bad, but hopefully you understand it's a function of my pen up here and not a function of me trying to hit the asymptote. You want to come off of here, you want to get asymptotic, well, it really becomes this pain. So what a lot of people will do is you make a really fat graph and you've covered everything there, right?
For the left.
See, we're in punch up.
For the left. Is always reciprocal.
Well, that's what 1 over b is. When you look at 1 over b, that means the reciprocal. So even when we were in growth, like if the growth factor was 2 on Friday, the reciprocal of 2 is 1 over 2, which is what you would get when b is a 2, right? So if b is already a fraction, 1 over, in this case 1 over 5, look, that's what we're doing. 1 divided by 1/5 is the same as 1 times 5 over 1, which is 5. It's just easier to think whenever you see this, hey, just take the reciprocal. Okay? Now this one is more than just the parent graph. What's different about this one? A negative vertical stretch factor. What is the parent graph?
Y equals 1/2.
1/2 to the x. Don't say b to the x, be specific. What is the translation vector?
0, 0.
Vertical stretch factor?
-1.
-1.
Y equals 0.
Oh. So there's not much to this list compared to the parent graph, except for the vertical stretch factor of -1, but that does have a huge impact on what our graph ends up looking like. So through 0, 0, we draw our horizontal asymptote. From the origin, we're going to go right 1, up 1, or we go right 1, up b in the parent graph. What are we going to do in this graph? Right 1,
Down.
down
1/2.
1/2.
Right 2.
Right 0 up 1 for the parent graph becomes right 0 down 1. And left 1 up 2, left 1 down 2. So this is the same graph we did 2 slides ago. Y equals 1/2 to the x was the parent graph right here. And here's your landing. We have a negative vertical stretch factor, which you've learned over time that all we're going to do is flip this over the asymptote, or over the x-axis, and we're going to get this graph. Is everyone following these, the 3 points and how the graph looks with the asymptote and the list? What you see is all I need for graphing. I do not need a t-chart. We are not plugging points in for x and getting y's. Not going to happen. Okay? So here's another one that's already done for you with a vertical stretch factor of 3 and 2/3 is your base. So no stretching or no translating, but a stretch of 3 is right 1. Instead of up 2/3, you're up 2 because you're multiplying up 2/3 by 3. Instead of right 0 up 1, we go right 0 up 3. And then instead of left 1 up 3 over 2, we go up 9 over 2, or 4.5. And we have a nice smooth landing here. Don't be in a hurry to go from this the point on the right 1 up 2. Don't be in a hurry to get down to this asymptote. It's a nice smooth, think about making a skateboard ramp here. All right, we're not in a hurry to kill the kid on the bottom of the ramp. So we need to make it nice and gradual. Everybody good here? Try this one. See if you can get a graph for that. I'll give you the list up here. See if you can go ahead and fill in the list. See if you can go ahead and do the graph. Okay, what is the, let's see, parent graph, I think I can handle that one. Y equals 3 over 4 to the power of x. What's the translation vector? 0, 0. Vertical stretch factor? Negative 2. So the horizontal asymptote is y equals 0. Because there's no translating, the asymptote will always be y equals 0. Right 1 up 3/4 in the parent graph. What are we going to do?
Times it to negative 6.
Which is negative 1.5, right?
Yeah.
So right 1, negative down 1.5. Bless you. Right 0,
Down negative 2.
down 2, and left 1, down
4.
8/3. Left 1, down 8/3, which is 2 and 2/3. Is anyone not seeing those values? We can show you them worked out if you're not getting them. So once you have your 3 points, then it's just a matter of making a nice smooth approach to that asymptote. So your graph should look something along those lines. You have to push the asymptote from those points, but it's got to be a nice smooth curve. This is what we would expect you to have. If it doesn't look like that, something's amiss. Let's try one with the translation. Okay? See if you can fill in the parent graph, and then we'll graph it together. See if, or the list. See if you can fill in this list, and we'll graph this together. Again, if you don't make the list, you will lose a point for every single graph. This list is not negotiable for these. And I know some of you don't make the list typically. I know that some of you don't show any work on your graphs typically. It will be unacceptable for these graphs. Did you right there? I was losing you. Well, Lynn, what is the translation vector of y equals 1 times dx graph? 2, 1. Remember, it's the opposite of what's with x, and then d is what happens after the function. Right, Sarah, what's the vertical stretch factor? 2. The horizontal asymptote, the equation for the horizontal asymptote, Natalie, what'd you get? Y equals 1. Very good. Anyone not seeing those 4? Excellent. So throw the asymptote up there. 2, 1. Y equals 1. There's my asymptote. I usually put up, when I'm not at the origin, I usually translate right 2 up 1, and I put a little dot on that point, not to represent a point on the graph, just so I know, hey, I'm always starting and translating and doing my movements from that point. Right, that's just how I do it. So let's throw the graph up here. From the translated origin to 1, normally we would go right 1 up 1/3. Right 1 up 1/3. Jennifer, what would we do? Right 1 up. Right, that's the parent graph. So on this one, no, multiply the 1/3 by 2. This one? Did you put 1/2 of the vertical stretch? 2 times 1/3. 2/3. So we would go right 1 up 2/3. Are you with me? Okay. Christo, right 0 up 1 in the parent graph. Right 0 up 2, because we have a vertical stretch of 2. We double the ups. Robert, left 1 up 3 in the parent graph. Left 1 up 6 in our graph. Notice we, again, I don't care what the point values are. It doesn't matter to me. I'm not making t-charts. If you plug in a 1 for this equation, you're going to get 1, 2, 3, 4, 5, 6, 7. You're going to get 1, 7. But there's no need to do that.
I don't get the second one, right? 0, up,
Up. What do you do in the parent graph? Right 0, up.
2.
In the parent graph.
That's my question.
Okay, let's go back. Hang on. Gotta have that list here somewhere. There it is. You should have left 1 up 1 over b, right 0 up 1, and right 1 up b.
I wrote it.
Okay, that should be the same from Friday. Same notes that you studied theoretically on Friday. Missed it. Where am I? Here we are. So right 0 up 1, we're going to multiply the up 1 by 2, and we're going to go right 0 up 2.
Because the DSF is 2?
Correct. You multiply whatever you say after the word up, multiply it by the vertical stretch factor. Right. Go ahead.
No, you go ahead. Okay.
Parent graph is right 0 up 1. Do you agree with that?
Yeah.
After the word up, I said, let's do it again. Right 0 up 1 in the parent graph. Do you agree with that?
Yeah.
After the word up, what did I say?
2.
Okay, let's
Well,
do
1. You said 1.
1. Whatever comes after the word up in the parent graph, multiplied by the vertical stretch factor.
2. Okay.
So we're going to go right 0, up 2. Left 1, up 1 over 1/3, which is left 1, up 3.
Okay.
What are we going to do? We're going to go left 1,
Okay.
up
6.
6.
Got you.
Okay? Sure?
Yeah.
Once you have the 3 points, again, it's very steep here. When you come through the 3rd point, try to level off and make a nice smooth graph. Might get a little bit wiggly in here. But that's about what we're looking for. I don't care about the coordinates of the points. There's no need to worry about it. Any questions on this example? Okay, try this one on your own. See how far you can get. If you're having challenges, and then we can do the graph. Parent graph is y equals 3/4 to the power of x. That means right 1 up 3/4, right 0 up 1, left 1 up 4/3. I'm watching people struggle because you got fractions here. Maybe if you make that list up here, you say, oh, that happens. We're going to go right 1 up b. b is 3/4. Right 0 up 1. Left 1 up 4/3. If you make that list, it might help you with your graphing. The translation vector is going to be, what's the
5, 4.
translation vector?
5, 4.
5, 4. The vertical stretch factor,
-3.
-3. The horizontal asymptote, y equals 4. So before I even start graphing, I should take my point 5, 4, I make a little starter point there for myself, and I draw my asymptote right through it. This is what I'm supposed to do. Right 1 up 3/4, right 0 up 1, left 1 up 4/3. All of the ups we are going to multiply by
-3.
the vertical stretch factor.
We just sounded like kids.
So Ellie, what am I going to get here? Right 1 up or down?
1, 0. No. 1. Oh, wait. No, you're done. I got it. No, it's -9.
Yeah, it's -3 over 1. You don't really need a calculator to do it.
Isn't it negative?
Top times top, bottom times bottom. What do we get on the top? -9 on the bottom. -9 over 4 is -2.25. So right 1, down 2 1/4. Right 0 up 1 becomes, we're going to multiply by -3. Right 0
Down 3.
down 3.
And then you go.
And right or left 1 up 4/3, we're going to multiply by -3 over 1,
-4.
-4.
No.
So left 1 down 4.
But it's like.
Right? But it's a flipped over landing.
Left, right.
So we're going to come off of here, and we're going to push our asymptote, which we're not going to get to way out there. Don't be in a hurry to go from this point to this asymptote, because you're going to make the graph look wrong. Questions on this? Now the applications are the same applications that we had for growth, except these ones will be decay, which means instead of 1 plus a rate increase, we're going to do 1 minus a rate decrease. No different than what we did on Friday, except the pluses become minuses. That makes your B value in here between 0 and 1. When you think about something on sale, 25% off, what do you end up paying? 75%. 1 minus 0.25 is 0.75. That's your growth rate. This is a perfect example. When you buy a car, the car depreciates in value. In this example, it depreciates by 15%. So the value of the car starts at $25,000 and goes down by 15% per year for T years.
That's a lot.
What's 1 minus 0.15? 0.85. That's your growth factor. So when it says the exponential decay model V after T years, they want V to equal 25,000, your starting amount, times 1 minus R, 0.85, to the power of T. How could you figure out what this car is going to be worth in 4 years?
Plug in
4
instead of T.
for T. See if you can do that right now. See if you can get so after 4 years, the value of this car, Jesus, really? Calling on him. Remember, we are being recorded, so you might want to think about the
Cheaper.
sensors.
I didn't say anything bad.
How much?
1806.
How much is this car worth?
$1,305.06.
How about somebody else? I don't want you to be my accountant yet, Penelope.
$13,050.
13,000.
Oh, oops, I added zero. $13,050 and 6 cents. Point 15 cents.
No, 16.
16 cents. You told me. That explains why I thought it was such a
High school.
good car. It was like $1,300.
I like that.
Okay.
That's like the money you could get for like math.
For your application, second part or third part question here, it's asking you the graph I mentioned earlier, not interested in the graph. Right now, if you could say between this year and this year, between the 5th and the 6th, the 6th and the 7th, I'd be happy. So you're going to do guess and check. If you plug in a 7 for T, if you plug in a 7 for T, what do you get for the value of the car? 8,014. So it's a little bit too much. So we want to say between 7 and 8 years, you'll get a value of $8,000. I don't really care. We have a mathematical way to do it in a couple of days. So we'll just wait. Yeah. But you can't solve it, right? Can you?
No,
Why not?
there's no,
Yeah, you're solving for T.
yeah.
If you plug in 8,000 to your equation, that's exactly what you're supposed to do. When you divide by 25,000, you get 8 over 25 equals 0.85 to the power of T. You mathematically can't do that. Okay, there's a couple people in here who might be able to pull it off. Do you remember? Maybe?
Yeah.
the rest of us, you haven't seen it. So you have an inability to do it because you haven't been taught how to do it. So all I want you to do is get me a ballpark for 2 days. Hey, this is your assignment.